Would you like to learn the Godot Engine and create games in its programming language GDScript? Are you looking for a structured course for absolute beginners and maybe some YouTube sources that are better than most other videos?
Yes, please.
Then stay tuned. My 4 years of learning game development and how to make games as a hobby was often like this. Well, I don't know how to do that or this in code. Let's search for a tutorial on YouTube and just follow it to get a nice mechanic. And then after some copying, somehow it works. Nice. But how to combine mechanic A with mechanic B that I found in different tutorials. In this case, I was always dependent on my buddy who programmed, and then I concentrated more on game design and art myself. This also counts for the little 2D platformer Relic Hunter that we developed earlier this year. Especially when you're working in a super small team, it's good to have more than one guy who understands the basic of everything in a game, which is code. By following individual tutorials that only offer specific solutions to a problem, you don't really understand the engine you're working in and come up with your own solutions that fit your project. So logically, trying to code without tutorial lead to hard frustration. But that's not a real game dev who I am right now. It's time to face that skill. I searched the internet for a course that is not made by half experts, but by real devs. And I found GDQuest. What is GDQuest? GDQuest offers a range of great courses to get you started with game development and is developed by people who have over 7 years experience in Godot. This series, I would like to focus on the course Learn 2D Game Dev with Godot. It's still in early access, but in the final version there will be 19 modules covering 2D game dev. It uses Godot 4 and GDScript. It's packed with interactive practices, teaches programming from zero. They're good learning program practices that are directly integrated into the engine. And the maybe most motivating thing is a final project is a complete 2D game with solid systems that you can build on. Oh, and what I forgot is that the teaching style helps you to think outside the box and escape tutorial hell. Pre-ordering means discount. So I paid the painful $84. And now I will take you with me along my journey and try to summarize things that I learned so far in this course. Currently, there are 7 modules released. The first chapter, M1, is the introduction. It's mostly about motivation and expectations. It is recommended that you set aside several fixed time slots each week and write down your motivation. Time for Notion. This is a project management tool that I have been using for about 1 year. It's great to organize yourself in it. I want to summarize everything I learned about Godot there. I've been keeping track of time frames and motivations there. It's mostly finally create and test game mechanics on my own and to be a better support for my programmer colleague. And the time frame is I will do it daily on weekdays from Monday to Friday, starting at 6 in the morning and doing it for 1 hour. The course also recommended to avoid distractions and declutter the workspace, and so I did. Also, M1 wants you to sensitize you to think like a programmer and familiarize you with how to deal with code you are learning. The learning method of the 3 C's is as follows. Copy the code. This means observe and copying existing code for similar results. Customize, varying the code you have to achieve similar results. And create, composing with that what you learned, play with it and expand it. Now I'm really ready. Let's move on to M2. M2, getting to know Godot. In that chapter, I will summarize what I learned about Godot in the first interactive tour. We'll go over the engine's user interface and clarify the most important things. As this first part is a free part of the whole course, I think there's no problem to show this to you. So let's start learning. The tour is mostly about the 4 pillars of the engine, which are scenes, nodes, scripts, and signals. When a project is opened in Godot, you start in your main scene. As you can see, we're starting in a 2D scene, and this is the viewport. This is a sample project, and we can directly test it by pressing play here in the upper right. So we have a character that can move around with BSAD, and we can shoot with the left mouse button. And we actually can switch weapons with the mouse wheel. You can walk around, and there are some enemies that you can shoot. A healing pickup. And I think that's it. You just close it here, and you're back in the engine. We're currently in the viewport. This is also the place where you can select and drag things around and move it along the screen. So everything that you can see here is listed there under the scene tab. A scene can mostly be anything: a character, a chest, an entire level, a menu, or even, like you can see here, an entire minigame. We are currently looking at the scene completed project, which is listed under the files in the resources. Let's dive deeper into the interface and what you can do in the separate parts. There are runner buttons in the upper right, so the play button just starts the project. If you have previous levels, then it will always start with your first level. Let's assume this is level 3 or 2 and not level 1. Then you should use this button. Here you can test the current open scene. And if you want to pick the scene you want to test, then you press this button. There are also hints for shortcuts. Moving on to the context switcher. This is findable at the center top. And there you can change between editor views. We're currently here at the 2D view, but Godot is also capable of doing 3D games, so we can just switch here. Of course, there is nothing here currently because we're looking at a 2D project. You can also see the script view. You can just press on player and see this script if you want. And the last tab is the asset library. There are many tools, projects, shaders, assets you can download to spare time or pimp up your own project. And there we have the scene doc that I mentioned earlier. It's at the top left, and these are basically the building blocks that make up the whole level here. Each little thing here is a node. A scene is made up of one or more nodes. These little icons help you to orientate which node you're looking at. This little mannequin here, for example, is standing for the player. There are many nodes to draw images, play sounds, design animations, and more. Now we are at the file system doc. This thing lists all the files used in your project, whether they are in your scene or not. This is including assets, images, scripts you made, or sounds, for example. On the right is the inspector doc. You can view and edit properties of selected nodes here. For example, if I select the player, a lot of stuff is appearing here. You can also tweak variables from mechanics you already implemented. This is really convenient for playtesting. At the bottom you find the output or debugger panels. Also, you will find here a possibility to edit animations, to write visual effects like shaders, and work with audio. Back to the scene doc. The highlighted area shows the complete scenes node. The completed game has 4 nodes: main, bridges, invisible walls, and UI layer. There are also scene instances. Other elements like the player have an open in editor icon. These scene instances are basically a copy of another scene. You can think it as a scene that uses another scene as its template. In Godot, we nest scene instances to create complete games. So let's click here. Now we are inside the player scene. This updates not also the scene doc, but also the viewport. You will surely notice inside the player there are also nodes, but nodes by themselves will do nothing. That's why scripts are attached to nodes. You can see it by this little document icon here. You can always click on these little icons to directly open the scripts. So we are currently inside the player script and the viewport has adapted. This code's language is GDScript. Code tells the computer exactly what to do. So any node can have a script if you like to. Moving back to the 2D view, we can work in the viewport with many tabs. So we could see the player or switch to the completed project scene. In a game, there are surely objects that you want the player be able to interact with. This could be buttons, doors, chests, levers, or other things. To do what you need them to do, these elements need to report events to the game to trigger the action you expect them to trigger. That is called a signal. Signals are marked by this little wavy icon here. If we click on it, on the right side where the inspector is, you will notice there's another tab for nodes. And inside you can hear now if there are active signals inside the player node. As you can see, the list is really long. Nodes emit many signals because there is a lot of stuff to react to in the game, like collision, health, or the player dead. When a signal is connected, it looks like this arrow is going inside this little green door. That means that in this example, player health is changing each time Godot will run the connected piece of code. We can double click it to just jump into this section of code where this signal is connected. Also highlighted here. This function here updates the display of the player health bar. Let's run the game and look at the updating health. That was a signal at action. So let's summarize the 4 pillars on which your games rely in Godot. Scenes, reusable templates that can be anything in your game. Nodes. Nodes are the building blocks for your scene. They can be seen in the viewport. Scripts. These tell the computer what to do. They can be attached to nodes to have influence on their behavior. Signals. Events that nodes emit. They can be connected with the scripts to run the code when an event happens. I hope this introduction gives you a little overview of the engine. I don't know where I got this from, but I heard the best learning method is to learn something as if you wanted to teach it directly to someone else. And so I will alongside this course. Let's finally move on to the 3rd chapter, M3, Learn GDScript. It's time to face the programming language of this engine. This whole chapter is a free part of this course available for everyone. During this chapter M3, it will occur that I will sometimes switch to other sources due to practice problems I have or some frustration walls, and I want to be transparent about how to overcome them. Let's select a lesson. What code is like? Lesson 1. And go. In every lesson you will have a theoretical part. There are some practical examples, some multiple choice stuff, and it always ends with in-app practices. It's your task to code a solution for a problem. Let's go back to the start and summarize every lesson. And let's see how I perform on each lesson's practices. Looking at the questions in between lesson 1 is the essence. How do you give instructions to computer using a program language and precise instructions for the computer? Are programming languages all completely different? No, they have many similarities. And mostly important, if you want to give it a try too, programming is a skill, and like every skill you have to practice it. So don't get mad like me if you fail at some practices at first. So let's go to the first practice. I think this is the easiest possible because I don't have to change anything. We're just telling the computer here to give us the text output welcome. And there it is. Let's continue. We're now in the second lesson, your first error. Errors help you to identify if and what you made wrong and help you to correct the code. Errors are not a bad thing at all. They're good. They're here to help. Let's go to fix our first error. Encode everything with the hashtag before. It's just for your information. This is something the computer should not take care of. To make this work, you just have to move it in this example. And there we go, the third chapter. We stand on the shoulders of giants. In Godot, we use code that many programmers have used before us and build on it. Code bundles are called libraries. There are many of them in Godot, which make it easier for us to develop games. For example, the functions that we call. These are developed by the Godot developers. A function is a list of instructions with an exact name, like you saw in the last lesson. This function, for example, has a specific name, run, and it tells the computer to hide the object. To define a function, you need to write the func keyword, the function's name, parentheses, and a colon. And afterwards, don't forget to use a tab to tell the computer what follows is inside the function. You can also give the function arguments. Like here, we want to rotate the character only by 0.3 radians. So you fill in a so-called argument in here, which makes the character turn a little bit every time the function is called. The first question, what does the code below do? It calls a function named show, and it also makes the entity, like a game character or a sprite, visible. Let's face the third example. Here we're combining more than one instruction into the function. To move the character to its left and right axis, we're using two other functions inside this run function. Give them the arguments to move it by 20 pixels. You may ask yourself why the character is moving down when I type positive number here. In school or in math classes, the vertical axis points to the top, but in video games, the vertical axis points down instead. So whenever you move something on the y-axis with a positive value, it will move down. How do you call a function? What is the syntax you use to call a function? In general, you write its name followed by an opening and a closing parenthesis. Moving on to the practices. First of all, we just want to make the character visible. Second task is to rotate the character by 0.5 radians. And we are good. Chapter 4, Drawing a Rectangle. As we saw in the last chapter, we can make a character move. This is also shown with this function. But we are not bound to one instruction. As we already know, we can store many instructions in one function. The turtle is not only moving by a certain amount of pixel, but also turning to another direction. Adding additional instructions makes it more complex. In this example, we're drawing a full rectangle. In the function call below, which part is the argument? It's the 30. Now we should try it on our own. The instruction is to move forward to 200 pixels and turning right by 90 degrees, then move forward again by 200 pixels. Now it gets more complex. We should now draw a rectangle of 200 by 120 pixels. And we're done. The next rectangle should be 220 pixels by 260 pixels. But this time the calls of the functions are also missing. So we have to write them on our own. Move forward by 260 pixels. Turn right by 90, and then we can make it easier for us by just copying the already existing code. And we're done. Chapter 5, coding our first function. Functions can have any name. These can be chosen by your own and very specific. If you use them otherwise in code, this will lead to an error. This function name is also called identifier. It's the best to choose a name that has some context about the function and what it will do. For example, here, move and rotate. That's exactly what the turtle does. Or here, draw a square. We are not bound to certain arguments in our function. There are possibilities to write any square with one function. To showcase this, we have a little slider here. You can draw a little square for 20 by 20 pixels. But we can also go up in size, like 80 by 80 pixels. Or to max it out, 200 by 200 pixels. Again, we are looking at how a function is actually built. We start with the keyword func, an empty space. Then you can give the function a name. Parentheses and a colon are following. Inside a function, you will store one or many instructions. Beware of the leading tab character to tell the computer that these instructions happen inside the function. Think of it like a box or a package. Why do we use functions? To run multiple instructions in one go, to reuse code multiple times, and to put a name on multiple lines of code. When you want to give your function a name that contains of more than one word, you cannot use spaces between these words. This would lead to an error. So instead of space, you can use an underscore Or more commonly, when a new word is starting, you start with the first letter in big. And remember, you can also not start with a number. Which of the following names are valid function names? You cannot use it because of the space in between. Here it starts with a number, but this is fine, and this is fine. Now we want to draw rectangles with the turtle in different positions. So we let the turtle jump in between. Our task is now to code a function that is named drawSquare and to draw one square of length by 200 pixels. Oh, I forget this thing here. Now we go. Now it's our task to draw 3 squares and to make a jump in between. Do not type this down endlessly. We're just creating a new function that is called draw 3 squares. This time I'm not forgetting this semicolon. And then we can call the already existent function or package. If you like it like that, or it's easier like that to imagine, 3 times. And in between, we want to jump for this amount of pixels. This has to be executed 2 times to not draw in the same position. So actually I stumbled over my first problem. On the first side, there's no difference between the suggested solution and my code. Func draw 3 squares, draw square, jump, draw square, jump, draw square. Maybe you have better eyes than me, but actually now I'm not understanding the difference between the solution and my way. I would just ask my colleague. Maybe it's super obvious and it's a perfect example for you at home, trying it on your own and being not frustrated with something that doesn't work and find solutions or other ways around it. Oh man, this took me a while, but as always, it's just one tiny mistake. And there we go. We made it. Chapter 6, your first function parameter. In a previous lesson, we gave the rotate function an argument. What is a function parameter? A label you give to a value the function receives. So it's not bound to text. It can be a number, a text, or anything else. Or anything else. Again, you can create functions with any name, like in a previous lesson where we drew circles of any size. And here we get reminded of that. which is the correct syntax for a function definition. Functions are not bound to a single parameter. They can have multiple parameters. After the first parameter, you work with a comma and a space, and then continue. When defining a function, parameters are optional. What's the correct syntax to define a function with multiple parameters? Now it's time to draw corners of any size. So we just have to type the parameter length here, there, and there. Now we're using multiple parameters. This means we also want to draw any angle parameter. So just like we learned before, let's add it here and also here. And there we go. Now we want to draw a square of any size. So let's create a function draw square. Use one parameter, length. Move forward, turn right, and repeat it. Again, I think. And there we go. Now we want to make the function more flexible, including rectangles of varying sizes. We'll use length and height for this. So length, height. Chapter 7, Introduction to Member Variables. So now that we know that we can give a function a parameter that can have any value, we can only make them specific and change over time. For example, with health. In this example, we create a variable that is health and it has the value of 100. You already know this one. This makes the character rotate. But if you, for example, tell rotation is 0, in this case it would reset the character to 0 rotation. So what's a variable? A label you use to keep track of a value that can change. There are also sub-variables, for example, for the position X or Y. In games like we covered before, the y-axis is positive going down. We can not only do this with the position of a character, but also with any other stuff, for example with the scale. This reminds of Super Mario when he gets his mushroom power up, where he doubles his size. So how do you access sub-variables? Let's go on to the practices. So we want to draw a rectangle of 200 by 120 pixels at the X position of 120 pixels and the Y position of 100 pixels. There we go. Now we want to draw squares at different positions. Draw 3 squares of size 100 by 100 that are 100 pixels apart on the horizontal axis. In other words, there should be a 100 pixel gap between 2 squares. And we're done. Chapter 8. Defining your own variables. We can and we should define our own variables. This is really useful for health or endurance, damage, or other stuff like that. When something is changing, we can ensure that it has changed in the way that we intended and test this with the print function. In this case, we are subtracting 1 from the value 5 health, then we're printing result, which is 4. Variable is always defined in GDScript with for space, then the name of it. You cannot reuse this exact same name. That will lead to an error when you're defining another variable. In this example, we gave health the value of 100, so it prints 100. Here we're changing it to 50, so it will print 50. The print function can also be defined in what to print. In this example, it's hey there. So variables are like a label. You can stick stuff at it, so you're not bound to numbers. You could also give it this text here, and it prints this is some text. Let's move on to the practice. Define a variable named health with a starting value of 100, or health equals 100. Chapter 9. Adding and subtracting. Now we're changing the health by subtracting or adding a certain amount. In this case, the amount specified as the value 25. So when the character takes the certain amount of 25 damage, death is going to be lower by 25 points. This can go on and on, but it doesn't stop at 0. It continues. This is a problem that we solve later. This minus equal is the same as this line above here. So you spare time, don't have to type it all over and over. Here we are adding 25. We're facing the same problem here, that it doesn't stop at the intended maximal health. It just keeps adding and adding. So which of these would increase the health of the robot? The short version and also the long. Let's move on to the practice. Now we want the robot to take 50 damage. There we go. Don't forget to define the amount. So this would be the same, but now we're adding stuff. Oh. Forgot the parameter. Now we're going. Yeah. 10. The game loop. This process function with the parameter delta is rotating the character for 0.05 radians per second many times. So it's basically looping. How many parameters does this function take? So it's 1. And as you can see, it continues to rotate. So how often does the process function run? It does run multiple times a second. practices. So this is the function. Now we want to rotate by this certain amount. And we're done. Now we want to rotate, and at the same time we want to move it to different positions. So we're using move local X in addition here. And like every time, it's some silly writing mistake. 11. Time delta. In the last lesson, we learned that the process function could make the character move continuously. But it's not only the character that has such a process function. In fact, the whole engine runs many of these all the time to update the game world. After that, it displays an image of the game world on the screen. We call that image a frame. Godot then moves on to calculating the next frame. And this happens multiple times per second. So we get the illusion of movement. That's similar to traditional animation. And you may have heard of frames per second. Games run often 60 frames per second. Well, that would be nice. It means that everything in the game updates 60 times each second. But this can vary. On powerful computers, you get higher frame rates, and on weaker computers, you get lower frame rates. What parameter does the process function take? Well, it's delta. So frames take varying amounts of time to calculate. No matter what device we use, the impression that the character moves fluently or other stuff works fluently, we're using the delta parameter. It represents a time difference. That's the time passed since the previous frame in seconds. So if we ignore delta, the game experience will vary depending on the computer. We want to make it consistent for everyone. So what do we know about delta? It's a time difference. It's the time passed since the previous frame in seconds. And everything is right. We can now multiply by delta. So now we're making the motion time dependent rather than frame dependent. So yeah, to have a comparison with delta or not, you can compare this. On every device, this bottom robot will move differently. In my example, with delta, it's faster. So multiplying rotation speed by delta. The practice. At the moment, the rotation of the robot is frame dependent. Now we want to make it time dependent. The robot should rotate 2 radians per second. And there we are. Moving in a circle using delta. And this practice makes the robot move in a smooth circle. To get this movement, the robot should rotate 2 radians per second and move 100 pixels per second towards clockwise. Done. 12. Using variables to make code easier to read. Let's now make our code easier to follow and understand. In the above example, we know from the last chapter that this number 4 defines how fast the character rotates. Of course, we can guess what a number represents by looking at the function names, but it's harder to recall what this number does by quickly looking at the code. We learned in lesson 8 that we can attach labels to these numbers, which are called variables. As a recap, that's how we define a variable. Write var space, the variable name, spacebar, equals sign, spacebar, and value, shown in this example. Then you can use inside the function the label or the variable angular speed times delta instead of 4. In the above example, which line defines the angular speed variable? Var angular speed equal 4. If we define a variable outside a function, we can use it in other functions too, but we can also define variables inside of functions. But that means it only works function-wide. So when you're using the same variable here, it won't work. If you want to make it work here, define it outside the function. So where can we define variables outside and inside of functions? It's a good idea to group these stuff. Think about a platformer. You will have gravity, jump strength, horizontal speed. It's good to group everything that helps to control movement. Same goes for a combat system. In the practices, we define variables and use them with some familiar functions. So let's make the code more readable. We are told to do a variable that is angular speed outside the function, which is 4. And then we replace the 4 with angular speed. This works script-wide. Now we'll fix an out-of-scope error. Like we saw before, we want to make this variable work also in this function. But this won't work as long as the variable is only defined inside this function. So let's get it out of there. And there we go. Conditions, chapter 13. This is the one where the health problem comes back to us we faced before. We already learned that we can subtract or add stuff to our variables, like losing or gaining health or taking a heal. So yeah, this guy is like endlessly healing. And I just answered it, calling take damage 5 times 25 would subtract a total of 125 from 100. In the end, it would be like minus 25. We don't want this to happen. Normally, when the character reaches 0 health, it dies and respawns or the game is over. So we want to use the condition to run actions selectively. In the jump example, the computer checks is a button pressed or not. Then, when it's pressed, execute a jump. When it's not pressed, do nothing. We can also apply this to our health. If the health goes over a maximum value, we want to reset it to the maximum. In the heal function, we can add this amount when picking up a healing item or a heart pickup or something like that. And then the condition comes in. If the health is over the maximum amount, like 100, then reset the health back to 100. So back to the maximum. And there you see it stops at 100. Fine. But greater than is not the only option we can attach conditions to. We could also say if the health is below 50, then do something. Or if the health is equal to 25, then do something. Or if the health is not equal to 7, then do something. So pass is just a placeholder to make the code function until you fill in something else. Which of these statements are true? 2 smaller than 3, 2 is equal to 1. No, 3 is smaller than 1. No, 1 is not equal to 3. 3 is greater than 1. And there we go. We can also do an or else that comes afterward. We can say if the speed is 120 and it goes below 100, then print you're slow, or else do nothing. But in this case, when the value is above 100, we will print you're fast. So we're printing you're fast. Now we're using comparisons. These if statements are all wrong. Let's start with the first. It's actually health greater than 5. Then it said 1 is less than health. The third statement states health is equal to health. The last statement says health is not equal to 7, which is the exclamation mark and the equal sign. This time we want to create a function that limits healing. The health is never greater than 80. So if health is greater than 80, then health is 80. And I forgot the columns. There we go. Now we want to prevent health from going below 0. We imagine we are in a Japanese RPG and we take damage until the health is gone. And then we don't want negative numbers. We want to stop at 0 instead. We're taught to calling the function where the character takes damage, and then we say if health goes below 0, we set it again to 0. If health smaller than 0, then health is 0. Chapter 14, multiplying. As you know from many games, sometimes when it's especially character focused, you want to level up and get stronger. We could define it in a function like this, where the current level is level 1, and there's a function level up that increases the level plus 1. As we saw in earlier lessons, we can group a lot of variables together that could improve when we level up. But in this lesson, we just focus on getting more health with each level. For this, we could change the heal function that we already know. This is how it looks currently, but now we want to level up. The level is increased by 1. We're adding 5 health. Doing it like this would lead to a linear grow, meaning every time the character levels up, it just adds 5. What we want now is the exponential growth. This means with every level up, we're getting even stronger. To get this exponential growth, we multiply the max health by an amount greater than 1 each time the robot levels up. So what's the value of damage? We have var level 5, var power 3, and we multiply this. So it's 15. We can use this also like subtracting or adding amount. This also goes for multiplying. So looking at these numbers, we're here again at 15 times 2 equals 30. An exponential growth in max health would then look like this. We have level 1, max health 100, and when the character levels up, the max health, the current max health, multiplies with 1.1. Then it would be in level 2, 110. And when the character levels up to level 3, 110 is going to be multiplied with 1.1, 121. So you see it's going to be exponential. Let's increase the maximum health exponentially in a practice. So we have this current level 1, the max health, and now we level up, increasing the level by 1. And increasing max health by 10%. Yeah, so it displays just 121, but this is wrong, right? Increasing by 10% would be 110. So this is not level 2 here, mister. This is level 3. Oh, I'm missing something. Let's continue. Now let's reduce the damage we get at higher levels. So we're currently level 3. The health is 100 and the maximum health is 100. Now we have in these take damage function. I'm quite not sure here. Maybe it should stand above. If level greater than 2. This is also wrong. Let's stay close to the task. It's not set to change anything here. So if level 2 greater than 0, then change the amount. Change the amount times equal 0.5. Oh, hoppla. There we should go. Yeah, a tough one for me. Chapter 15, 2D vectors. Well, what are even vectors? Looking at this coordinate system with the x and the y axis, a vector is a quantity with a magnitude and a direction. For example, a force applied to some object, the velocity, speed and direction of a character, and so on. This quantity is represented with this arrow. When we are in the two-dimensional world, Godot names this vector 2. And you can see it here. It stores one number for the x-coordinate and one for the y-coordinate. So far we come across two variables in the course, which are vectors. Which are they? It's the position and the scale. Vectors are great for games. They're not only great, they're necessary if you want to make your character move at a certain speed and direction. So let's scale the robot again, this time by adding directly a vector 2. For that, we're adding something to the scale, then vector 2, and inside the parentheses, we're adding 2 arguments, one for the x, one for the y. And as we just knew from the question above, we can also change position with this. As you might remember, the y-axis is in games positive counting down. So that's why 20 by 20 leads to a right downward position. How would we make the character move to the left? Beware, this is position X, but we're facing a vector 2, so it should be this. Let's move on to the practice. Increasing scale using vectors. We're now told to add a line of code to the level up function, increasing the scale of the robot by vector 0.2 and 0.2. So scale, we add something, so it's a plus, vector 2, and there we go. Now let's reset size and position. of this way too big robot. For that, we should create the reset robot function, resetting scale and position. The scale needs to be 1 and 1. And the position should be set to 0, 0. There we go. Always tiny mistakes. Lesson complete. Let's now go to chapter 16. Introduction to while loops. We've already seen that we can use functions to reuse code. In this lesson, we'll learn about loops. These help us to repeat code. We now have the robot on, imagine like a board game. There are positions it can move to. Currently, he is at the center vector 2, 0, and 1. If we add 1 to the x and another 1 to the x, the character will move 1 and 2 to the right. We can also move diagonally by adding a vector 2 directly. So currently, we are at cell vector 2, 0, 0, and now we're doing this movement here. So this works with a board that is predefined with a specific size of vector 2, 3, and 3. But if this size was different, that wouldn't work. So we now need a general solution for any board size. For that, we can say repeat or move until you meet a specific condition or decide to break from the loop. Here it's expressed with numbers. We have number 0 and we're adding permanently +1, but we're telling why the number is under 4. When it reaches 4, it would stop. That's why this code, this is basically just stored now inside a function, would execute 4 times for 0, 1, 2, and 3. So let's apply this to our move to end function from the beginning. We have this function while cell x is smaller or less than the board size x minus 1. Then add +1 to the cell. Let's reset it. Let's make the size. There you see. We chose a board size 3 and 5 and, of 6 and 3, and it stops. That works for any board width. So while loops can cause issues as long as we are not telling them when to stop or to break. So here we have the var number 1, while number under 10, it should draw a square. But we're missing something here, so it would draw squares infinitely until the program is terminated. When should we use while loops? It's told here that we will not need this very often at the beginning. It's more intermediate to advanced level use. But there is an example that you already know. For example, games run in a loop that typically generates 60 images per second until the user closes the game. This is possible thanks to while loops. There are other good uses for while loops. Reading and processing a file like a text document, line by line, processing a constant stream of data, like someone recording audio with a microphone like I'm doing right now, reading code and converting it into instructions the computer understands, or various pro-level stuff. We don't need to bother right now. So let's face it and go to the practice. In this case, the robot's currently vector 2 is 2, 0, and we now want to move it downwards within the board size and then stop. So while cell y is less than board size y minus 1, then cell y plus vector, we're using the vector now, 0, 1. It's vector 2, so it's the whole cell also, not only y. To be honest, this is a good game example that it can be used for, but I must have had a hard time understanding the while loop while dealing with cell and board size also. Let me give you another example from an external link. You're here at gdscript.com and there are super tight explanations about the basics. So we're here at while loops, and there it said the while loop evaluates a Boolean expression to decide whether to keep looping or exit the loop. We have defined fuel and the speed the car is maybe driving, and we're saying while the fuel is above 0, so there's still fuel in the tank, we're increasing the speed while that leads also to less fuel. And when the fuel tank is empty, then we're not gaining speed anymore. I'll leave a link for this page in the description. It doesn't look as good as a browser app we're currently working with, but sometimes it's good to have other learning sources. And even if it's text, it might be not so visual, enjoyable, but for the brain it's sometimes good to switch between image input, video input, and text input. That helps with learning. Now we're conquering for loops. In the last lesson we looked at while loops, and they're useful if we don't know how many times we should repeat the code. So if we were not careful, the loop would go forever. That could cause bugs. So in the course it said there's a safer method for loops, and this is called the for loop. They don't run infinitely. You specify a range of numbers that determines the number of execution. So for example, calling a range with 3 in the parentheses, it outputs the list of numbers 0, 1, 2. If we give it a range of 5, it outputs 0, 1, 2, 3, 4. So print range 6 would print to the console 0, 1, 2, 3, 4, 5. So again, the computer takes each value inside a list and stores it into temporary variable and executes the code in the loop once per value. So you can be sure this is going for 3 times. 0, 1, 2. The number is just one example. You can give that variable any name you want. And you could also list every stored number here. That would work the same. Both upper examples reprint the value of the temporary variable we created. It was element in the second and number in the first. The app is just showing us what information is inside here, and that you could write everything that is contained here down, which equals to a way longer code. It works the same. This is how the move to end function from the last chapter while loops looked. We created a function to move to the end, and while the cell x is smaller or less than board size x minus 1, we move forward by 1 cell until we reach this. And if we use a for loop instead, it said that the code becomes a little bit simpler. So for number in range, board size x minus 1, the character moves as long as possible. And it also, of course, works for any board size. Practice time. Let's see if I can solve this. The robot stands here at vector 2, 0, and we should move to the bottom using a for loop, and board size is determined by vector 2 variable board size. So for whatever, move in range, board size y minus 1. Because we're moving alongside the y-axis, we should limit it here. Column, tab, cell, plus vector 2, 01. There we go. So now we have this previous example where the code is too long and we should make it linear and more elegant, sort of. So for jump in range, I could list this, right? Okay, taking a look at GDScript again. So for whatever in range, number, do stuff. So let me do that again. Then it should be like this, right? For whatever, do stuff in range 3. Okay, we did it. Taking a little look back at the second practice of chapter 17. Of course, you may have noticed that there is a solution button that can just show it to you and you can copy it. But I use this external source to come to that solution on my own first. And when I really get stuck, then I would hit this button and then maybe put these lessons in a dirty, forgotten corner and then redo it with a fresh mind 1 week later. So that's my approach here. Creating arrays, chapter 18. As we saw in the previous lesson, we can store a list of numbers in our for in range loop. So we see 0, 1, and 2 storage inside here. We can also write these values out and get the same output. This also counts for this approach here, just telling you can name it whatever you want. And this is like the unwrapped version that leads to the same output, just for the understanding. So the syntax of arrays is like this. So you start with this square brackets, value 1, comma, empty space, value 2, comma, empty space, and so on. And you end it with the square bracket that is closing. As you see here, you can also store a vector 2 inside here. Or as in the official Godot documentation shown, you can also store text if you have some, when you use it in those quotation marks here. So yeah, you can name it whatever you want. Better name it in a way that helps you understand what it stores. And using arrays can be helpful when you have lists of things in games, like the player party in an RPG, items in a player inventory, high score, or objects in the game world. All of those and many more rely on arrays. You can also use arrays to follow a path. Every vector 2 stands for a specific position. As you can see, the turtle can follow this path to reach the robot. So this path can be drawn. Let's now practice creating arrays. So we have this path here, but how to reach it? Using vectors could help. 2, 3, 4, 5, 6, 7. So I need like 7 times. 3, 4, 5, 6, 7. Vector 1, then 1, 1, then 2, 1, then 3, 1, then I have 4, 1, 5, 1, and then remove in the y-axis, so 5, 2. And there the turtle goes. Oh, it should reach it. Okay. Vector 2, 5, 3. And there we go. Okay, imagine we are in an RTS and we want to select units. We also do this with vector 2 coordinates. One O 0 3 5 1. Oops. And 03. Oh no, I had it. 3 2. No, 4 4 2. Yeah. There we go. In the end, it's just the brackets, right? Yeah. What else? Complete. Looping over arrays, chapter 19. In the last chapter, we used the range function, a combination with for loops, reference 0, 1, and 2. The range function produced an array that the for keyword could loop over. We can give for loops any array, and they will loop over them just the same. Instead of using the range function, we could manually write the numbers and get the same result. We already know this too. For each element inside the array, the for loop extracts it, stores it in the temporary variable named number, and executes the loop's code once. So yeah, what will this code print? It's obvious, right? We already made the turtle walk alongside a path by writing vector 2 coordinates. Here we're solving it with a for loop, and for each coordinate in the array, it moves the turtle once to that cell. The same works for unit selection, and here comes a lot of new stuff. For each coordinate in the array named selected units, so in each cell, we check if there is a unit, and if so, we select it. In that case, we use an array, a loop, and a condition together. A lot of new stuff here. In a condition, the in keyword allows you to check if a value exists in an array. We're using a period after the selected units variable to call the append function. It's because the function exists only on arrays. and functions exist only on a specific value type, you write a dot after the value to call the function on it. As we know from this course, we will face those features in later lessons again and build on it. So these loops work regardlessly of the size of your arrays. We can theoretically select 1,000 units here. Let's try to practice them. Okay, so we've provided a path for the robot to move alongside the cells. And now it's our task to move the robot. Call the move to function like so. Robot using a dot. Move to. Is it now robot path in here? No. I have to look for cells in robot path. Robot move to robot path. Move to cells, right? For cells in robot path, robot move to cells. Okay. We want to draw many rectangles. However, writing this code by hand can get tedious. Instead, you could store the size of your shapes in arrays and use a loop to draw them all in batches. That's what you do in this practice. So we're using a for loop to draw every rectangle in the rectangle sizes array with the draw rectangle function. And we need again to jump so that the rectangles will not overlap. Yeah, so actually I had to look up this solution this time because at the moment this part confuses me a little bit. Also when I run it, this is kind of overlapping here, but it shouldn't. That kind of confuses me this time, but that's part of the story. Maybe you know a better solution or an explanation. Yeah, well, I think it's good to show you also this kind of stuff when I get stuck, and we'll come later back to it. The good thing is for each chapter there is a specific forum. So I wrote this down and told the people there who are also attending this course and the creators that I get stuck here, and maybe I will get some help after this. Yeah, let's take, although we are at chapter 21, have a look back to chapter 19, practice 2, where I had a problem understanding it and I wrote something in the forum. And just after 3 hours, one of the creators tried to help me with this and explained the code and why it worked like this. So yeah, the array here of the rectangle sizes contains all 4 vectors, each having one coordinate or size for x and one for y. So for every size in rectangle sizes, draw a rectangle according to the sizes and then jump. And this is the part I didn't really understand, because I question myself why the turtle can only hop between the rectangles on the x-axis. So he tells me you're not limited to moving only on the x-axis. You can move however you want, using the size x or size y. So this is possible, but it wasn't possible in the practice, right? I think that is the stuff that confuses me. So it is possible, but the task or the practice wants you to write this. So I could make big jumps with any value large enough for rectangles not to overlap, like so. And for understanding, the edges we're touching, but this is not real overlapping. Yeah, so I'm really thankful for this super fast answer and see that you get immediate help if you get stuck. We move on to chapter 20 now, which are strings. We mostly stored numbers and variables, but this goes also for text. I told it before, if we use these quotation marks, we can store text, like here, the name of the robot. Under the hood, strings are arrays of characters. In fact, we can use a for loop to loop through the characters of a string with any other array. So you see, it's every letter. Which of these are strings? I'm not sure, but this should count 2 then, right? No. Ah, of course. Why we use strings? Well, in fact, we can inside an array store strings too, like for chaining animation when we're performing a combo. So we have var combo, every animation, one jump, hit, hit, jump, level. Then we perform it here for action in combo, play animation, action. Okay, now the robot needs a name. In this practice, we chain together animations using an array of strings. So we have a jab, an uppercut. Yeah, that's it. 2 jabs followed by 1 uppercut. Okay, jab, jab, uppercut. Well, they told me I can name it whatever I want, right? Or is it now just animation? Animation name. For animation name in combo, animation name. That's the problem, the tab. Okay. That was at least a little bit easier. So, chapter 21, functions that return a value. Returning, yeah, what is returning? When we return a value, we're sending it to the place what you call a function. That's why in this example, the round function takes the decimal number as an argument and returns or gives you back a new number rounded to the nearest digit. Here we want a clean number, so we get 3. This also works for like showing health points. We have the rounded health. This is the round health. Reusing it here and set text so that it's not like 39.8 when it's close to 40, and also when we are like on 67.4, it's 67. Another example is lerp function. This is short for linear interpolate. It calculates and returns a weighted average between two values. And it takes 3 arguments. It can be used to animate things moving towards a target. And this time we get the local mouse position, we get the position, and we're multiplying it with delta for a kind of smooth movement. We can make our functions return values. To do this, we use the return keyword and then followed by the value. Maybe you remember from previous lessons, we had robots walking on grids or the turtle, and we were working with concrete cell coordinates. But these don't correspond to positions on the screen. To find the center of any cell on the screen, we need to convert the cell's coordinates to position on the screen. And this is shown in pixels. First, it multiplies the cell coordinates by the cell size, which gives us the position of the cell's top left corner on the screen in pixels. Then we add half of the cell size to get the center of the cell. Function returns the result, allowing us to store it in a variable. Yeah, we're using the size. We define the cell size in pixels, then we define inside the function var world position is equal to convert to world coordinations. That's the vector we wanted to convert, and then we're printing correct coordinates in pixels. So some functions do return stuff and others don't. An example that does not return value is the void. Yeah, converting coordinates from the grid to the screen as shown here. That's exactly what it wants from us. They're different arguments, but it's basically the same. There we go. Moving on to appending and popping values from arrays. By the way, if you still stick with me, it's just 6 lessons to the finish line, so don't give up. Before, we learned how to create arrays to store lists of values and how to loop over them. But the real strength of arrays is that you can add and remove values from them at any time. It allows us to queue or stack data. For example, this is useful when we want to track orders in a restaurant managed game. So the customers are placing orders and then need to handle them as they come. And the orders end up in a queue. We need to prepare them in the kitchen. So the orders are coming and arriving and then getting completed over time. For that, we use this code. We're using the append and the pop front function for this. These can only exist on arrays. So we're breaking it down. First, we queue orders in the waiting orders array by appending them to the array. We can give the meals a string so they have real names. When completing an order, we move it from the waiting orders array by calling the pop front function. This function gives us the order back, so it returns it, which allows us to assign it to a temporary variable. We can then append the order to our completed orders array. Yeah, and stuff beginning with a hashtag is more like a note you take. The computer will not execute this line. It's just for you later to make it easier to read or to show what the code exactly does. So you can describe it here. Before we go into using arrays as stacks, I want to do the first practice completing orders. Inside here, rating orders will be filled over time, so it's not our job to care about here. We're just caring about the completed orders. So var completed order is equal to waiting orders pop front. Hoppala. Then the array completed orders dot append completed order, right? Completed order. Okay, this is wrong here. And this also. There we go. While that is solved, we don't continue to the second practice. Now I go back to using arrays as stacks. Yeah, this is useful, for example, when you want to list stuff in an inventory or inside of crates that you can loot. So inside this array, there is a sword, we have gems, and we have a healing heart. And we're taking these items from top to bottom. So use top crate, var crate, crates pop back, use crate. First the heart, then the gem, then the sword. What is new here is the pop back function that is appended to the crates array. This removes the last value from the array and returns it to you. In this example, pop the last value of the array and print what's left. So gems should be removed. And there it is. Like the pop front, the pop back returns the value removed from the array. And while this is removed from the crate, you could, for example, give these resources to the player inventory. Let's go to the practice 2. We want to clear up crates, but this time we also have a while loop in here, because we should be careful. If we run a while loop carelessly, we can lock the software. Our code should remove all the crates in the array using a while loop. So we are told to check if the crates array still contains values. So writing while crates. Then don't forget the tab. Crates pop back. And that's it. Chapter 23. Accessing values in arrays. We learned to loop over all the values in an array using the for keyword, but of course when you're in an inventory, maybe we want to access the third item, the second item, or just the second last item. As you already know, we list after the array name the index that contains all items. But now I can say use item inventory 0. So then only the sword is used. Be careful, because 1 is the second element in the array. 0 is the first. So when I'm telling the computer inventory 3, I would use the 3. But if I ask how would you access the third item in the inventory array, then it's the heart. I can also do this with the last values. This is super useful when the list is way bigger than this. So I want to use the second last item here, which is the shield. How would you access the third to last item in the inventory array? Then it's inventory -3. So if we want to access something that is not here or inside there, you will get an error. We can only access existing elements. We can check for these valid indices. One of them is checking the array's size. Arrays come with a member function, and this is named size, appended to the inventory array. So it contains 4 items. The maximum index we can access in an array is array size -1. It's the last item in the array, so this hard. Let's use the right items now. In our game, the player has an inventory that works as an array under the hood. We want to equip a sword and a shield to buff our character. Like before, we need to find them in the array. We need to access elements in the inventory array by the index to do so. Then we should call the useItem function with the item as an argument to use it. For example, you can use the first item by calling useItem inventory 0. We definitely want to use 2 arguments. It doesn't work. So do I need to access them separately? Maybe. Yeah. Realigning the train tracks. There's some train tracks broken down here into little chunks. We use them to make modular tracks. However, several chunks are misaligned. You need to find them in the tracks array and pass them to the align function. To do so, we need to access the array by index. This time though, we need to access them with negative indices because they are like the last items before. Let's align these tracks. So separately, right? Like in the last practice. Moving on to the tracks and then working with negative numbers. Can I just copy and paste this stuff? And that's it. Creating dictionaries. Chapter 24. In the last lesson, we used arrays to represent a place inventory, but just names though don't tell you the amount of each item. So to solve this, we can bundle item names and amounts into a single dictionary. That is a data structure that allows us to map pairs of values. So like item name and amount. You can also see it here. We have 3 healing hearts, 5 gems, and 1 sword in an inventory. These can have any value to any other value. In this example, it's a string matched with the amount, so a number. But these could be a string, a number, or even a vector. But this, what stands here before, the so-called key, has to be unique. If there is a duplicate, so for example we have healing heart again later, then it leads to errors. So in this above example, we have a double healing heart. That will cause an error. We accessing these values by having keys inside the dictionary. How would we access how many gems the player has? So we have 5 var item count, inventory, gems, changing values. we can also change values directly. If we are, for example, adding or removing items from the player's inventory. Like here we're adding 1 healing heart. Let's use a dictionary to create a player inventory and create a function to change the value of items. Let's add some items to the player. So inventory variable is already here, and now we should give them keys and an amount. So starting with the first string, healing heart, and then the amount of 3. Next would be gems with the amount of 9. Then there is sword with the amount of 1. Let's move on. Increasing item counts. Now we want to add an item to the inventory. So we're accessing, what did I do? Curly brackets. There we go. So we have item name. And then we want to add an amount. So it's just plus e. What? It's plus amount. Yeah. Nice. Looping over dictionaries. Chapter 25. We are almost done. Like with arrays, we can loop over dictionaries. We can loop over keys and values. For displaying the player's inventory, we need to know what it contains. We need the name and the amount of each object. And from code, you can only achieve that by looping over the whole dictionary, processing key value pairs one by one to get the list of keys in the dictionary. So we want just this. We can call that is appended to the inventory. And then we get healing heart, gems, and sword. But now it's told that we do that so often or so much that we don't need to call the function. There's a better way. Instead, we can directly type the variable name in a for loop after the in keyword. So for item name, in inventory, print item name. This would lead to the same output. You can get the values with the syntax dictionary key as we learned in the previous lesson. We can loop over the inventory keys and display all that info in the user interface. So checking item names in inventory, item count is equal to inventory item name. Then print the item name. This is like the format, and then the item count. And then we get keys plus amount. And instead of printing this stuff, we can code and call a dedicated function that displays items in the user interface. Mapping grid cells to units. As told before, keys can be also numbers, they can be strings, and they of course also can be vector 2 coordinates. That's why we can use a dictionary to map units to their positions on a game board. That's how I typically code a board game, a grid-based RPG or a tactical RPG. And of course, no duplicates allowed. Every key must be unique. Using a for loop, we can use the key value pairs to place units at the board at the start of the game. For a cell in unit cells, var unit is equal to unit cell at unit. cell. So we're adding a robot at 1,0, a robot at 3,0, and a turtle at 2,2. Let's practice this. First, we're displaying the inventory. Let's try this. For item in inventory var the amount is not defined. Display item and amount. Oh, am I wrong? Yeah, so I just smashed my keyboard. And there we go. This should be it. Oh no. That's correct. Yes. Now we want to place units on the board. We have 3 units. The keys are defined as vector2s, and there's no amount, but there is a string to tell the code what type of character is placed where. And now we really want to place it on the board game. So for cell in units, var unit, var unit type units. Oh, there are the brackets. My keyboard sucks. And there it should be cells, right? Display, no, place unit cell and unit type. Or unity type. Wow. And it should be cell here. Yeah. Good. Value types, chapter 26. We almost did it. Let's play some music in the background, so it's less dry, I guess. Who cares? While we're vibing a little bit, let's check value types. So we already know some of them due to previous lessons, such as whole numbers, decimal numbers, strings, 2D vectors, arrays, and dictionaries. The computer uses this type of a value to know which operations and functions you can use with them. But they are not fully compatible with one another. So misusing them will cause errors. Sometimes you have to convert a type of a value. So we want to display the player's health in the interface. The code tracks health as a whole number, a value of type int, short for integer. But if we want to display it on the screen, the computer wants text. And that's a string, right? We can connotate 2 strings with the operator. So what we want is health plus health. But this will lead to an error, and therefore we do, as I said, convert a value by using this function. This will transform the health to a string, and we can display on the player's screen health 100. Of course, the other way around is also possible. Therefore, we use the int and the float functions. So we have a 10 as a string, and to give it as a whole number, we use int via input. Then we got a number instead of a string. Most types are incompatible. For example, you can't directly add or multiply an array with a number. However, sometimes are partially compatible. For example, you can multiply or divide a vector by a number. There we go. But we cannot directly add or subtract a number to a vector. Then we get an error. That's why in earlier lessons we had to access the sub-variables of position to add numbers to them. Yeah, a surprising result. Take the following division. We would expect 1.5, right? But it gives us 1. That's because the computer has only the information of whole numbers here. So it tries to give us an output of a whole number. Because it's 1.5, it rounds automatically up. If we do it like so, we are more precise. That's why it can output 1.5. So yeah, we have to be really specific and mindful with types. Otherwise, we will get unexpected results. Understanding and mastering types is a key skill for developers. So it is a common mistake to struggle with this at the beginning, and GDScript hides these types from you by default. So if we don't understand that some are incompatible, we can get stuck. So let's practice some type conversions. Let's start with displaying the player's health and energy. So we want to display the energy here, but it's a number. We need a string. So we're starting with this. Oh. And we converted it. Letting the player type numbers. Yeah, so imagine we're in an in-game shop and we want to let the player type numbers to let them choose which item they want to buy or sell or add to the inventory. Yeah, so we need to know the number of items as an integer, but the computer reads the player's input as a string. That's why we're using the int function and convert the player's input into a whole number and store the result in the item count variable. So item count, convert the player's input into a whole number and store the result in the item count variable. Oh, this keyboard. And I do it like this, and then the int function, and then we use player input, right? And it worked. Nice. The last chapter, finally. Specifying types with type hints. Let's do this. By default, GDScript is a dynamically typed language. So we can just write variables, assign them a value with a number, and assign them another value with a different type. Unlike in other languages, in GDScript the following code is valid and it puts out some text. This feature causes problems down the line. Let's have an example here. Imagine we are using grids for grid-based gameplay, and therefore we need to convert grid coordinates into positions. We give each cell a size in pixels. For that we use either float or the vector value type. It's recommended to use a vector 2 because when converting grid coordinates to game world coordinates, that would be simplified by this. In this example, because both cell and cell size are vector 2, we can add them. But if cell size is a float, we will get a type error. But here it's stated that due to the dynamic typing, we maybe won't get an error right away, and that's a huge problem because as you continue with your own project, code gets way more complex. And then finding an error that is not clearly displayed, oh, that's hard. So here is a solution using type hints. GDScript has optional type hints. These let the computer know the value type you want and report errors before running the code. So that's how we write it. var space variable name colon space then the type space equals sign space value. So we could tell the computer we want the cell size only to accept vector 2 values. Variable name colon space type and then here the value. If we try to replace the cell size with the value of another type later, like so, the computer will not let you. And there you have a real error message. Yeah, and there's also a possibility to let the computer figure it out. This is called type inference. So we could write colon equals sign without the type, and then the computer will set the type using the value after the equals sign, vector 2. So we could make cell size a variable of type vector 2, like so. So why should we even bother to add hints? As told before, it will prevent major errors. As we learned from, I think, one of the first lessons, errors are good because when they're displayed, we know if we get used to them and the specific error types, how to solve them. And yeah, using type hints will make us learn types much faster. As said in the lesson before, beginners often struggle with these types. So let's write the correct type hints to make the code error-free in the last practices. Okay, we should correct the type hints to variables. Vector 2, this is like an integer. There we have a string. And this is, wait, decimal number. Ah, we didn't use that, right? Or didn't use that before the float. Okay. Fix the values to match the type hints. Okay, so it's the other way around, right? The string here. Well, that's an int. And then we have a float. And I'm lazy. Just copy paste. Ah. I should match it. What am I doing? Now we're good. Oh. Now we're good. Oh. Now we're good. Now we're good. Yeah. We did it. We did it, we did it, we did it. Nice. Yeah. It will lead us automatically, have a click here, to the courses you can pay for. As I told you before, that was part of some free courses here. I think you can find them directly under the tutorials. Yeah. Under tutorials, learn game creation, Godot tutorials. There we go to Godot learning paths. There's Godot interactive tour. That's the one we did earlier in the video. And then we have also learn to code from zero with GDScript, what we just did. Yeah. There's a lot of stuff here for audio, 3D, design patterns, networking, procedural generation, shaders, user interface. Yeah. A lot of stuff inside here, a lot of really great stuff. The rest of this 2D course is paid content, so I cannot, I cannot show this to you. But I will show you results applied to an own project, so we can still keep track of the progress I'm making. I will link you everything down in the description. And if you search for free good alternatives on YouTube, I would say, here it is. Go with Clear Code. They give you an 11-hour ultimate introduction to Godot. Yeah, even way longer than my video. And of course the good old brackeys who made this 2 Godot videos just some weeks ago, and the good heartbeast, a programmer with a lot of experience in game dev with Godot, and his videos are super easy to follow. He's a great guy, so yeah, I highly recommend him too. And yeah, let's see what the future brings. I hope it helped you in some way. Sorry for the last video. Feel free to like and subscribe, and we'll see you soon, my friends. Bye bye.